So this time there are theorems in order to prove if the two triangles are congruent. So the first theorem we have the side-side-side congruence postulate, or that is SSS postulate. So given these two triangles here, triangle ABC and triangle STU are given triangles, and they are said to be proved by SSS, or the side-side-side congruence postulate, because the corresponding sides of these two triangles are congruent. Okay, how can we identify if they are congruent? By this symbol here, this line here. This line here signifies or tells you that these corresponding sides are congruent. So segment AB corresponds to segment ST, and that is they are congruent by this symbol line here. And also if the second line, two lines, and that is the second line, TU. And the third lines, or three consecutive lines, ayan. Third line also congruent. Oh. Next, the side-side-side theorem tells you if three sides of a one triangle are congruent to the three sides of another triangle, then the triangles are congruent. So if segment AB is equal to segment ST, segment BC is congruent to segment TU, and segment AC is congruent to segment SU, and that is it. Then triangle ABC and STU are congruent. Okay, another theorem we have the side angle side congruence postulate. Okay, from the name itself, side, two sides, side, angle, side, side, angle, side. Okay, so if two sides and the included angle of one triangle are congruent, the corresponding parts of another triangle, then the triangles are congruent. Okay, so segment AB corresponds to segment ST, so they are congruent. Angle A corresponds to angle S, so they are congruent. Segment AC and segment SU are corresponding sides, and they are congruent. Okay, so when you say if you have all these two pairs of sides and an angle between those two sides, okay, so triangle ABC and triangle STU are congruent. Another postulate we have the ASA congruence postulate. So ASA congruence postulate tells you if two angles and the included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. Okay, so what are they? We have two angles from A and A, and the middle of them between those two angles is a side only. Okay, so angle A corresponds to angle S, so they are congruent. Side AC and side ASU are corresponding sides, and they are congruent. And another angle, okay, we have angle C and angle U are corresponding angles, and they are congruent. If you satisfy those given, okay, a pair of angles, two pairs of angles and a side between them, so these two triangles are congruent. Triangle ABC and triangle STU are congruent. Then the last one we have AAS congruence postulate, o angle side congruence postulate. So two consecutive angles and a side. Okay, angle, side, angle, side. Okay, so if two angles and the non-included side of one triangle are congruent, then the corresponding angles and non-included side of another triangle, then the triangles are congruent. So if we satisfy all these two triangles here, and a segment, okay, not between them, so let me say triangle ABC and triangle STU are congruent. So let us try some examples here and answer all of them. Okay. In these examples, you need to choose the best theorem to prove the following triangles are congruent. So we have a figure. This one is quadrilateral or a rectangle, PQRS. Okay, and it divides by a diagonal PR. Okay, so what's the best theorem to prove? So we have four with that we discussed. So we have the side, SAS, ASA, and AAS. Okay. So in here, in this figure here, we can prove this using the side angle side here. Why? So we have they share the same diagonal, which is diagonal PR or side PR. They share the same side. Okay, and then an angle. Okay, angle R, and it is corresponds to angle P. Okay, so they are congruent. If you see this symbol here, meaning say they are congruent. And QR corresponds to PS. And if you see those symbol, meaning to say they are congruent. So let us name it side, angle, side. Okay. So we can use the side, angle, side theorem in order to prove that these two triangles are congruent. Next, how about this one? The same as the previous example. Okay, what theorem suits uh, for this? SSS, SAS, ASA, and AAS. So this time we can use the SSS theorem. Okay, wala naman nakalagay na angle. Okay, by looking this one, why SSS? So S segment AB corresponds to CD, so they are congruent. Segment AC corresponds to BD, and they are congruent. And how about this one? Segment CB. So they share the same side of a triangle. Okay. So segment CB is also has a segment CB, so they are congruent. So that is the third side. So we can use the SSS congruence postulate. So please disregard this answer. The right answer here is SSS, not B. Okay. How about this one? This time we can use the SAS. Why? Because LP, okay, this side LP is the second side. Okay, because these two triangles here, SLP, is congruent to RLP because they share the same side, which is LP. Okay, LP. They are reflexive actually. Okay, so segment ST corresponds to segment RT. And angle T or angle STL and angle RTL, okay, are corresponding angles. Okay, then they are congruent. And then this one, LT, they share the same side, which is LT. Okay, so that is the second side. So that is side, angle, side. Okay, how about this one? Choose the best theorem to prove the following triangles are congruent. This one is ASA. Okay, by looking at this figure, angle N and corresponds to angle N, and we have a single side, and the third angle, side angle, angle, side angle, angle, side angle. Okay. Next, let us complete the congruence statement in each pair of congruent triangles. Tell what congruence postulate is, illustrate them. So triangle MOL, triangle MOL is congruent to triangle SPT. So in here, the first triangle, we have MOL. Okay, stand corrected. We have triangle MOL. This time, we need to start in S, then followed by T, and then O, and P. So S, T, P. Okay, so what theorem? We need to apply the SSS postulate or theorem. Okay, in order to prove these two triangles are congruent by looking at these three symbols here. Okay, and here. Next, another one. We have this one. Triangle NEM. And it is congruent to triangle since we started to N, and N corresponds to P, and N followed by E and then M, then this time P followed by O and Y. So triangle POY. Okay, and then we can prove this using the AAS postulate. So why AAS? So we have angle, angle side, angle, angle side. So we can use the AAS postulate. Next, how about this one? Triangle RTU. RTU. Okay. And the congruent angle is STU. Okay, STU. Because angle S or side ST. Sorry. It's not STU. It's so side ST corresponds to side TU. Okay. So RTU. So it will become RTU. Okay, and then this one S RTU. So it is SVT. SVT. S sorry. It's not SVT. It's VTS. Okay. VTS. From here V and then R VTS. Okay. So we can use the what theorem? So it is SAS for me. It is SAS. Why? Okay. Why is it? Because this angle here. Okay. These two angles here are congruent. Okay. Because please take note of this. Vertical angles are congruent. Okay. Like you say, this one is a vertical angle. Okay. Vertical angles. So when you say vertical angles are congruent. Angle 1 and angle 2 are congruent. Angle 3 and angle 4 are congruent. So that is the definition of vertical angles. And measure of angle 3 and measure of angle 4 are congruent. This time, okay, this angle here, okay, is congruent to this angle. Meaning to say they are vertical angles. Okay, so side, angle, side, side, angle, side. Okay, so that is SAS postulate. And example here. So triangle ACD. Oh, sorry. Triangle A from here, and then here, and then here. Oh, this time triangle ACD. So what theorem are we going to use here? So we can use the SSS postulate. So why it is SSS postulate? Because they share the same side, which is side AC. And all the parts of this triangle are sides. Okay, meaning to say AD corresponds to AB, CD corresponds to CB, and they share since they share the same side, which is AC, so we can apply the SSS postulate. And